Hi everybody, in this video we're going to learn about the Cipher cipher, a very simple encryption mechanism that makes it easy for you to write a message, encrypt it, and then send it off, and without someone knowing the exact logic you use for encrypting it, they won't be able to make sense of your message very easily. And so what we're going to look at is, first of all, how this whole Cipher cipher works, and then we'll start building the exact example you see on screen, both the UI as well as all the logic under the covers that makes this work. It's going to be covering a lot of fun topics, so grab some popcorn, get a chair, and maybe a code editor if you're also wanting to follow along, and it's going to be a lot of fun. So let me first take a look at what exactly is needed for the cipher to work. There are two things you need to provide as the creator of the message. The first thing is you need the original message, in which case I just have the word hello. And the second value is a shift value, which indicates how far the message is going to be different from what you started off with. And so in this case, if I have hello and a shift value of 2, the output is JGNNQ. That probably, you're like, wow, this is really amazing. It's encrypted. I have no idea how to go backwards from it. Let's actually take a step back and take a much simpler example. I'm going to type in ABCDE. And I'm going to put a shift value of 0. What this shift value does, it simply specifies how far to move each letter from its starting point to something else. So with the shift value of 0, our input is ABCDE. There's no shifting going on, so the letters stay the same, ABCDE. But if I provide a value of 1, what this means is that what once was A will now be shifted over by one letter. It'll become B. What was originally B will now become C, and you kind of get the drift. So if I add a shift value of 1, you'll notice that the output is BCDEF. I'm basically incrementing each letter by moving it one position. Similarly, if I put a value of 2, you now see it is CDEFG. And of course, if I go much larger, like 14, it is now OPQRS, which just means that A shifted 14 positions over is O, B shifted 14 positions over is P, and so on. And so let's go ahead and dive deeper into some of this by jumping to some slides first, and then we'll jump into some code to go into more of the actual implementation side of all of this. So let's say we have an original message. Let's say it's the 3 words, pizza, pizza, pizza. Pretty simple, and if you have ever watched the Little Caesars commercials for their pizzas, it is something that you'll see all the time that their mascot often says. And no, I'm not being paid by Little Caesars for making this message. Now let's say we shift pizza, pizza, pizza over by 2 letters. This is the output, and which in many ways is not very intelligible, but if you kind of know the pattern you're going for, it's going to go backwards by 2 letters and get back to what you're trying to do. And the way we're going to make this work is this. Imagine our alphabet. We have 26 characters in it. Each letter has a number. In this case, A is 1, B is 2, C is 3, D is 4, and so on. And it goes all the way to the very end, where we end at 26, where the letter Z happens to be. Now, when we shift each letter, what we're really doing is not just shifting the letter from a visual point of view, which is very valuable for us to understand what's going on, but we're actually shifting it numerically, where when it's shifted by 1, we're moving from one value to another. And the important part to kind of note is that this makes sense for a lot of letters we have here, but what happens at the very end? Let's say we add Z and we need to move over. All that happens when we do that is Z just wraps around. We imagine that you have your letters, but you wrap it in a circle, so the end of Z is not the end of our alphabet, it's merely a temporary location where the next letter now becomes A again, and the cycle repeats itself over and over. And this is an important detail to keep in mind, because when we think about encryption, the values we might provide may be very, very large or very, very small, and we want to account for that. And the easiest way to do that is by treating our entire alphabet as an infinite circle. So getting back to our example, we went from pizza, pizza, pizza to RKBBC repeated a handful of times. And the way we did that was by shifting each letter by 2. Now, when we go one level deeper, in JavaScript, each letter has a numerical representation associated with it, or each character actually has a numerical representation associated with it. And when we focus on just letters, we start with A is 97 and Z is 122. And these are lowercase letters. The uppercase versions have their own numbers as well, but for what we're going to be doing, lowercase is all we're going to be caring about. You'll see that all of our letters have a number that happens to go from 97 on the A side to 122 on the Z side. And so when we talk about shifting, what we're really saying is that I'm going to shift by in this case by, like, let's say 10 characters. And what this means is that I go from X to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I end up at H, which is 104. Now you're wondering, wait, how does a shift from 120 get us to 104? Shouldn't it be like 130? The reason again is that we talked about earlier is our entire alphabet loops around. So when you get to Z, we start over from 97 again. So it's 120, 121, 122, then it starts back at 97, in which case from that point you are actually at 104, which is the value of the number you're at. So you can kind of see like how our visual view of the world makes a lot of sense. We need to translate that into a world that our JavaScript and our code understands as well, which is a great segue into our code editor. Now, what I have here is a very simple page. Nothing going on here. It's just a local document called Cipher.htm, and I have the exact same page open on the right-hand side. You can see that when I change it from, let's say, document to say Caesar Cipher, the title updates, which kind of indicates that the page I'm displaying here and the page I've loaded here are all part of the same workspace, and everything is kind of working well. And so there's going to be a fair amount of HTML, some CSS, and some JavaScript. And the best way to bite this off is to just start with HTML. I like to start with the HTML structure just so we have an idea of what it is we're dealing with. And then from there we add the logic and then go in phases as we build our application up from having nothing to having a fully working solution. So let's first start with the development. We need to have a parent container. Div class equals, I'm going to call this main container. And this will really house all the content that we want. So the first will be Caesar Cipher, our heading 1 tag, and you can, let me zoom in a bit just so you can see more of what's going on here. Right, you can see Caesar Cipher displayed in all of its giant size. Then we're going to have a handful of input elements, both label and input, to kind of map what needs to be displayed. So label equals for original, and the message is going to be original message. And next line would be the input that corresponds to it. So input ID equals original. Well, I'm definitely not having the best of luck today with the quotation marks. Type equals text, and let's go have the initial value be pizza, pizza, pizza. Why not, right? You know, it seemed appropriate given that's what our slides started off with. So label for equals shift, and the value is going to be shift, and then the input that corresponds to it will be input ID equals shift. This input is very straightforward right now. We will come back to it later as part of building out the example. We'll modify it a little bit. Add a good old horizontal rule. And lastly, now it's going to be the input for showing our actual output itself. Label for encrypted is going to be encrypted message. And then lastly, the input ID equals encrypted, type equals text, and value is going to be empty, and let's go and make it read only. We don't want to have the output be something you can interact with or change. You know, we could, but we're not going to, because why not? And the last thing I'm going to do, which is entirely optional on your end, is I always like to have like a link to going back to the home page. So I'm actually going to skip it. No need to have that here. All right, so we have our Caesar Cipher. We have the example here. You can see that there's some text, there's some input fields. It doesn't really look like a whole lot. Now, the amount of CSS needed to make this page look, you know, presentable is a fairly large amount. And so to simplify things, I'm going to just reference the CSS file, which I encourage you to do as well. And then we'll walk through the CSS just so you have an idea of what it is we kind of skirted adding manually. So I'm going to do the link rel equals style sheet, and href equals https www.croupa.com/include/cipher.css. Okay, and once I've done that, you can now see all of this content makes its way here. And I know that I typically don't like to just reference a file and not talk about it, so let me go ahead and get the contents of it here. And let me create a new document, select the language, let's make it CSS, and just paste what it is we're talking about. And so when we look at our CSS, there's just a lot of styles that are going on here just to make it look the way it does. And to simplify reusing values a bit, I'm using some custom properties, primary font, dark gray, white, dark gray. And then throughout the document, I'm just specifying these values as part of setting the font for our heading, or being able to specify the color of the borders or the color of the text. And so nothing too bizarre or out there is happening here. The CSS is actually very straightforward compared to many other things we're doing. In fact, I'm not doing any of the new modern CSS tricks for pulling some of these examples off. And so I don't want to spend too much time here because the real interesting part is in the JavaScript logic. But I do encourage you to, when you get a chance, after you have your example fully working, to go back and make sure that you take a look at the CSS that you included, just so you have an understanding of everything that's going on. And if there's anything that's confusing, feel free to ask me. I'll have links in the video that talks about how to get in touch with me in the easiest way. All right, so what we have now is something that looks sort of like the final example that we wanted before, but if I were to just type in something, nothing is really happening. Now that's because the logic for everything needs to be done as part of our encryption happens to live entirely in JavaScript. And there are multiple steps to how we're gonna make the logic work. The main one is we have some input that we display on screen, and we want to read that input and have it be fed to our encryption logic, which will then take the shift value, adjust which letters can be shown when, and then send it back to our screen. When I explain it like that, it seems really simple, but when we look at the code, it's still that simple, but it just requires a lot of hand-holding in terms of coordination between what different parts of our code do, and that hand-holding is something that you and I will be doing writing JavaScript. And so let's go ahead and get started. And so the first thing I'm going to do this is by adding a script element. And instead of trying to do too many things at once, I'm going to hard code some of the values we need initially, just so our encryption logic doesn't need to require us to do input and do all this extra work on the UI side, when we can just work on a more self-contained part entirely in code. Which means that the original message, I'm going to hard code it. I'm going to set it to A, B, C, D, E, F, G. And for shift, I'm going to set it to let shift equals 1. And so I'm just going to bypass the UI for now and have the amount we need to shift by on our original message kept as variables hard-coded in our JavaScript. And then I'm going to type in a function called start encryption. And it's going to have just a console.log. It's going to say something happens. Very informative. And let me go ahead and call start encryption as well. And oftentimes, I like to do is, once I have the basic of my application running, have the console.log show up at a very early state, just so I know that what I'm building and what I'm doing is still working. There's no random errors. And you can see something happens, displays on screen. So far our application seems to be working and looking the way we think it should. I'm going to go ahead and close this right now. All right, so now that we have this, the next step is, okay, we need to go ahead and change the letters from what we have here based on the shift value. And so the first thing I'm going to do is I'm going to create a value called encrypted message. This is going to be our final output, and it's going to be an empty string. Yes, there's no encryption going on right now. And for each letter that we have in our original message, what we want is a shifted value from it. And that to me indicates there'll be a loop involved in some form. So I'm going to do a for letter of original message. You can definitely do a more traditional loop where we have a variable, a counter, and so on. But in this case, we don't need the index in any way, so this makes it very convenient. And I'm just going to type in encrypted message plus or equals letter. Now, all I'm doing here is taking each letter and just copying it over to encrypted message. So if I look at our console right now, actually let me go ahead and console.log encrypted message. We'll see what needs to be displayed. We can now see that each letter A, B, C, D, E, F, G is displayed on screen because, again, there's no actual shifting going on here. It's the same letters that are being put into one word. And the way we're going to change that is, I don't want this to just be letter. I want it to be the shifted version of letter and what needs to be there. And so I'm going to take the shift value. I'm just going to make it a little simpler here. And I'm going to move it into start encryption. You don't have to do this, but you're going to see why it makes sense because we don't want it to be a more global variable. And I'm going to create a function here called shift letter, and there's going to take two arguments, letter and the shift. So letter is what's going to be provided as part of the loop. Shift is what's going to be provided as part of the hard-coded shift value. And now what we're going to do is write the actual shift letter function. And so shift letter takes two arguments, letter and shift, which makes sense given how we're going to be using it. And inside it, I'm going to provide the logic for how we're going to be shifting all the various characters. Now, we saw earlier that each character in JavaScript, and in many programming languages actually, happens to have a numeric representation associated with it. And so what we're really going to be doing here is getting the numerical representation for the letter we're currently in, shifting it by a certain position, and returning the shifted position of the letter back to encrypted message, so that way shift letter returns the correct character to display, the correct letter to display, as opposed to what the input value is. And so for this one, I'm going to say let new letter equals, it's an empty string, nothing is there yet. And then now I'm going to go ahead and translate from the letters that we see in more human-friendly terms into the numerical character code versions. So let letter code equals letter.char code at, and it's going to be 0. And then let new letter code equals letter code plus shift. Okay. And so all we're doing here is we're getting the numerical version of what happens, which puts in the domain of the shift value, which is a number, and everything in new letter code is just the combination of what letter code and shift ultimately return. And now I'm going to check to see if the letter code we're in happens to fall within the range of A to Z that we care about. And so if new letter code is less than 97, this is a case where we end up shifting to a value lower than A, then I'm saying new letter code plus or equals 26. And the reason again is that, let's say if shift value is like -10, for example, and we happen to shift everything over, we need to make sure that if you're going below A, we increment by 26 characters above, so that way you're still within the right range of numbers, which is 97 all the way to 122, which is a kind of a quirk in just how we're solving this. There are many other approaches to solve it, and by the time we're done, we'll have one more adjustment we're going to make to how we make sure the values we're going to be resulting in will be within the range of A to Z. And then else if new letter code is going to be greater than 122. And this is the case where we're going the other side, we go beyond Z. We want to make sure that we still go back here. In this case, new letter code will be, let's see, will be minus or equal to 26. That way we stay within the 26 range. Now, the last thing we're going to do is that right now we happen to have everything in the form of a number, a character code. Now we need to go back to a letter itself. So I'm going to set new letter equals string dot from char code new letter code, which means that we went from numbers back to some text. All that remains is return new letter back to whatever we called. All right, and so now with shift letter doing its thing, it means that if everything worked out properly, what we had earlier, which is A, B, C, D, E, F, G, will actually be now shifted by 1 to display B, C, D, E, F, G, H. So right now, let's go and refresh the page. Actually, it's already refreshed automatically when I save. Let's see what the output is when I go to console. And you can now see B, C, D, E, F, G, H being displayed on screen. And the reason that shift value is doing the right thing. So just for checking, I can change it from 1 to 2 and hit save. And you now see that C, D, E, F, G, H, I is being printed on screen as well. So shift value is behaving the right way it should. And that's also being represented by a shift letter function, which is taking the shift value and then doing all of the right things here, which is in many ways a good spot for us to take a step back and go, all right, our logic for how to do encryption works fine. The next step is we currently are hard coding both the message and the shift value when we have two perfectly fine UI elements that we can be relying on to do that work for us instead. And so what we're going to do now is add some UI elements to make all these changes work to read what we're going to be specifying. And so when we go back to HTML, the two elements we're focusing on right now are original and shift. Original is the ID value for what original message is going to be, and then the shift value is that determines by how far to encrypt our current text. So and then of course the output for our encrypted text is also under the encrypted name. So the first thing we're going to do is, just after we have original message, or just above original message actually, let's make it the first things we care about, is reference these DOM elements. So I'm going to let original input equals document.query selector hashtag original. And I'm going to copy this section here just so I'm going to save some keystrokes because we'll be typing in document.query selector a few times. Let shift input equals, in this case instead of original it'll be shift, and likewise let encrypted input equals document.query selector, and it's going to be encrypted. Now one of the biggest areas of typos and mistakes in our code is having the name be misspelled from what we have in our HTML. At least a nice thing about VS Code is if I double click on some text, it highlights the appropriate values it matches in our document. And here, as you can see that the word encrypted, shift, and original are spelled correctly and match what we're seeing here. That's no guarantee that I didn't make other mistakes as part of it because I am coding live along with you, but it is at least a good sanity check that we're on the right path here. And so now to get the original message, what we want to do first is I want to store the value of original message. So let original message is ABCDEFG. I actually want it to be original input dot value. That means whatever we have specified in our HTML as our initial value, which in this case pizza, 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 is what's going to be stored by the original message. So no more hard coding there. And then now we want to make sure that each time a character is updated, new values entered in our field, that we call some code and we make sure that the original message is updated to reflect that. And so original input, dot add event listener. And the event I'm going to be listening for is input. It has to be in string form, input. The value is going to be character entered, and it's going to have a value of false. And then what this character entered event handler will be doing is ensuring that whatever value we enter not only updates original message, but we do some validation as well. Because what we want is our text to be lowercase and only be letters. No numbers, no special characters, no emojis, none of that. Only letters, lowercase, A to Z. And there's several ways we can do that to ensure it. And so the first thing I'm going to do is I'm going to store the value of original message. I'm going to set it to e.target.value. So each time a type in our message is being updated, we store that value right here. And then I'm going to set original message, set it the value of it to be equal to original message equals original message dot to lowercase. This ensures that what we're providing is lowercase letters, so no more uppercase letters. And then we're going to use a regex function to make sure that the values entered are only going to be letters, so no other characters are allowed. So original message equals original message dot replace, and here's where the regex function is going to go, slash bracket upper arrow caret A to Z close bracket slash, and then nothing to replace it with, just leave it empty. And the last thing we're going to do is set it back to e.target.value, write the value back to original message, and then call start encryption once we have this done. And so you can now see where I have my original message. If I type in like A, B, C, everything's fine. I'm going to type in 1, 2, 3, 4. And when I type 1, 2, 3, 4, you can probably hear on the keyboard that some keys are being pressed, but you're seeing nothing is actually being updated. And the reason is that our input event is fired the moment we see text a change in a character that's being provided here. And our code ensures that if it's not a letter, which is really this regex function right here, to just ignore it, leave it blank, don't bother putting anything inside there. So I can do A, B, C, and if I type in 1, nothing happens. But if I type in D, it goes back in. So this is one way for us to ensure and then validate that the values we care about we only want to support are just lowercase letters. So that's not too bad. And so now the next step is we have to shift. What do we do about the shift value? And so for our shift key, we're going to do something very, very similar. So the first thing I want to do is that you saw how we had logic for ensuring the values are lowercase letters in original message. For shift, what we want are the values to be numbers only. And the nice thing about numbers is that our browser provides some built-in validation to ensure that numbers are handled on its own without us having to do any extra logic, at least for the common cases. So I'm going to type in type equals number. And the moment I do that, like when I go to my shift value, you can now see there's an up and down arrow that appears at input size. Different browsers do different things. I'm in Chrome right now. If I was viewing it in a mobile browser, giving this input field focus will give me the more numeric keypad on all the modern phones and iPads and tablets and so on. And so it's kind of great to be able to specify type equals number and have a right thing happen from a user experience point of view. But more importantly though, if I type in like A, B, C, D, E, nothing happens. But if I type in a number, everything works out just fine. So what this really means is that all the logic we wrote here manually will just handled automatically by the browser by saying type equals number. So I'm going to specify a value of 2, our default value to be 2, and placeholder is 0. So that way, if you don't have any value specified, you see that 0 is what you should prefer. So it's a nice little hint for you to provide there. And so with the shift value, just like before, I'm going to go ahead and create an event listener that's going to represent what happens when the input value changes. And so for here, I'm going to type in shift input is going to be shift input dot add event listener. It's going to be input again, is the name of the value, number entered, and false. So don't care about bubbling right there. And then there's going to be a function called number entered. I'll put it right after our character entered function. Function number entered, E for the argument for the event handler. And all I'm going to do here is just call start encryption. There's no need to call anything else because all the logic that we had earlier is handled by the browser itself. So now that we have start encryption being called, let's make sure we are actually using the value of shift as opposed to it being hard-coded. There's several ways to do this, but I'm going to be using the more shorthand approach of doing if and else. So I'm going to do shift input.value. And if this value, let's see, well, what is this value? Is it going to be a numerical item? Number shift input.value. If it is, great, use that. If not, default to 0. So this is a very shorthand way of doing an if else. If shift input.value equals to number, great. If there is no value, that's number, or if it's something invalid, default to 0. A little shorthand way of writing some of these statements that you should look into as well. And so that is good. The last thing I'm going to do is, now that let me go and take the console log message out. We have our shift set up, we have our original message set up. All that's left is encrypted message, making sure that we have the output of this all displayed properly. So I'm going to type in encrypted input dot value equals encrypted message. All right, and so notice that once I hit save, you can now see the output displaying RK, BB, CR, the appropriate value. If I do ABC, you can now see CDE being displayed. If I go to shift value of 0, it's just ABC. If I do 1, it's BCD. If I do like -1, it's ZAB. So we can now see that the message, what we're typing, and the shift value, they're all being represented appropriately. Now, there is one optimization, or actually it's not an optimization, it's a bug fix that we need to make. So let's say we have ABC, and I'm shifting by a number greater than 26. Let's say I'm going to go with a number like 50. Notice that once I do that, look at the encrypted message. It is YZ and then a bracket. If I do like 500, you see some really truly otherworldly characters that appear from the giant map of characters that our computer is aware of. And the reason for this has to do with our logic for ensuring that we clamp all of the shifting to be within our 26 letters that we care about, because this only works if the shifting is within a range of 26. When you go beyond that, then we kind of are in a zone where we shifted by the maximum 26, but where we still are with the letter that we need to care about is still beyond A to Z. And so the solution for this is to, instead of shifting by 26, which is still the correct answer, we're not going to add shift directly to it. We're going to add the modulo of shift, which is shift %26. And what this means is that it normalizes our input to be within this 26 range, because let's say you have a large number like 52, it's going to be just 0. But if it's going to be, let's say it's 54, it's going to treat it as like, let's just subtract 26 enough times from it until we are left with the value of 2. And so in this case, if I now type in, like, let's say 200, I still stay within the range of the A to Z, whereas before we saw some really bizarre characters. And so this works for positive numbers and negative numbers, and you can see, like, when I'm doing 26, it's still pizza, pizza, pizza. If I do 52, it's still pizza, pizza, pizza again, because that's how the modulo and remainder operators work. And so with that, we're in VS Code. Let me go back to the slides. And well, that's not the slides. This is our example again, which is exactly what we kind of started off with. But to summarize what we did, we wrote some HTML, which contained all of the input fields and the output fields, things we cared about. And then we went directly from that into adding some CSS, including the CSS from a file that I already created. But we looked at what goes into it, which is just basic styling to make our example not look like we just created it just for the sake of writing some code, but putting some thought behind it, making it look a little bit visually appealing and different. But the bulk of our time was spent in the logic, where we went from how do we take some characters, how do we shift them by a number, whether positive or negative, and make sure we still get a value that stays within a certain range. See, talking about it out loud, it seems pretty straightforward, but as we saw, if you aren't familiar with string manipulation, especially in JavaScript, we learned about how character codes are mapped, how to go from a letter to a character code, and then back to a character code. Again, we looked a little bit at regex on how to make sure we can clamp the values to be lowercase letters itself, and then all the various glue that needs to be inserted to make all of the code properly work, like a change in the input field, updating our logic, or clamping down the values for the shift value to just be numbers instead of writing code for it, relying on our browser. So hopefully a lot of this is familiar to you. Congratulations. But if you learned something new, congratulations as well, because that's really the goal of it, is that some stuff familiar to you and some stuff is going to be brand new. And with that, if you have any questions, please post in the forums at formatcrypt.com, where I and others would be happy to help you out, answer any questions you might have. If you like this video, or if you didn't like this video, tell your friends and enemies all about it. Hit subscribe to be notified of new videos I'll be recording and posting periodically. Follow me at Krupp on Twitter and Facebook and other places where you might happen to see someone who looks just like me posting about web development topics. And lastly, I enjoy writing content, and you can read my stuff on the browser, but you can also read it in paperback and Kindle editions in book form. Yes, right, books, the ancient knowledge transfer mechanism that for whatever reason I still enjoy creating. And so check them out, link at the bottom of the video below. And with that, I will see you all next time.